A 10 kilogram block slides down a frictionless incline angled at 30 degrees above the horizontal. What is its acceleration? So this is an inclined plane problem, right? Where we have this plane, right, which has a 30-degree angle, and we have a block here. Now this is frictionless, okay? So there is no friction, okay? And we know that it is moving this way. So what are the components that we need to have memorized for this free body diagram? Well, we know that there is a gravitational force pointing always straight down, and then we know that it's going to have this component, right, which is going to be, remember, mg cosine of theta here. And then it's going to also have the normal force, which is pointing, remember the normal force is always directly perpendicular to the surface. It's not always directly opposing the gravitational force. The gravitational force is always pointing straight down from the center of mass. But the normal force is always pointing straight up from the surface, which is, it's always 90 degrees to the surface, right? This is m. And then we have this force, which is just the component of gravity, right, which is parallel to the surface, and that's going to be mg sine of theta. Right? So in this case, there's no friction, right? There's no friction. So the net acceleration in a sort of the direction that's parallel to the surface is simply the force in this direction is equal to ma, and the force in that direction is simply mg sine of theta, and that's equal to ma. So we just solve for a, the masses cancel, so a here is just going to be g multiplied by sine of theta. And g multiplied by sine of theta, what's theta? Well, theta is 30, right? So this is going to be 10 multiplied by sine of 30. And sine of 30, well, that is simply going to be 1/2. Okay, so 10 times 1/2 is 5, and that's going to be equal then to 5 meters per second squared. That is its acceleration. So B is the correct answer.